So in this question, there is a bead of mass m slides without friction on the vertical wall as a vertical circular hoop of radius r. So here you have a bead of mass m. Now this is going to slide in this vertical circular hoop. Okay, the bead is moving under the combined action of gravity and as well as massless spring K. So this spring doesn't have any massless. Above here, this is going to move because of your gravity and also because of your spring. Okay, because of the both the action, it is going to move down. It is going to slide in this direction. Now the equilibrium length of the spring is r. So this is the equilibrium length of this r spring. The spring is extended by a distance of r. Your x which is equal to r. In spring, the energy stored in the spring is what? It is simply half kx square. Correct. So here the extension we have is r. So half k r square. Okay. Here we have like this. Okay, if the bead is released from the top of the hoop with zero speed, okay, so here initially when they are dropping, they are not applying any velocity. So initially your kinetic energy is zero. Okay, only potential energy is there. Okay, so the question is, what is the velocity of the bead when the length of the spring becomes r? Okay, so when it is coming here, at some point of time your length of the spring will becomes r. When it is becoming r, what is the velocity of the bead? That is the question. Okay, we can apply energy conservation theorem. So let me draw that circle here. This is the circle. So initially this total height is 2r. So after some time, when it comes to its equilibrium length, okay, so let me consider this is this equilibrium length. So the equilibrium length is what? Your r. Upon this distance is r. If this is the center of the circle, and here this is also r and this is also r. Okay, and here you will be having 60°, here 60°, and here 60°. The energy, total energy at this point should be equal to total energy at this point of the bead. E1, let me take it as 1 and here 2. E1 should be equal to E2. What is the total energy at the point 1? Here your gravitational potential energy will be there and then spring energy will be there. Gravitational potential energy is what? mgh. The total height here is 2r, so 2r plus spring potential energy. Spring potential energy we already discussed, that is half k r square. So this should be equal to total energy at this point. So how we can find the total energy at this point? At this point we will be having the spring in the natural length, so there is no spring energy. So you will be having only your potential energy and kinetic energy. So here your kinetic energy is half mv square. So they are asking what is this velocity v, this is unknown, plus what is the potential energy at this point. We have to find what is this height. Okay, from the base what is this height we have to find. Up here if you see this is 60°, so this will be 30°. This is r. So if here if I apply sine 30°, what I'll get? I'll get opposite by hypotenuse. Hypotenuse is radius. Up here I will get your opposite as r sine 30, which is r by 2. This distance is what? R by 2. This answer will be what? mg into r by 2. So this is the equation which we are getting. Okay, now we have to solve this equation and we have to get the answer. So if this is the scenario, first what we can do, first we can write this equation again. 2mgr plus kr square by 2 is equal to mv square by 2 plus mgr by 2. So here we can cancel all this 2. We can cancel this, cancel this, cancel this. Here we can make this 2 as 4. So now I have to find what is v. We can bring this mgr left hand side up. We will get mb square, which is equal to, if I subtract this, I'll get 3mgr plus kr square. So here your v square is nothing but 3gr plus kr square by m. So if I want to find v, I have to take a square root. So I am getting 3rg plus kr square by m. So this is the answer.